These authors think they have a better version of a box plot. A box plot is an effective and simple way to present data. It gives you the median, the 25th and 75th percentiles, and it labels outliers typically using 1.5 times the inner quartile range. In 2011, these authors proposed a new type of box plot, which they called a letter value plot and is sometimes called an enhanced box plot. Is this really better than a box plot? The problem these researchers found with box plots is shown here. When you have a large data set, in this case between about 1,000 and 8,000 data points, you get a lot of points labeled as outliers, and these points are not necessarily true outliers. Even for Gaussian data, the probability of having an outlier labeled by a typical box plot is about 97% for samples of size 500. In my opinion, all of these outliers makes it really hard to read these plots. What do you make of all these points? The authors came up with this plot, shown here, plotting the same data. This looks a lot cleaner and clearer. There aren't as many extra outliers. You can see the boxes getting smaller as they move away from the median, and you can guess at the distribution a bit better than the box plot version. What are all of these extra boxes? Each box represents what the authors call letter values. They're basically repeatedly dividing the data in two. The first value plotted represents the midway point, which is 50%. Then it divides this in two and plots the 25th and 75th percentiles. If you stop here, that's a normal box plot. This enhanced box plot repeats the process again and plots the eighths, 12.5% and 87.5%, and it keeps repeating until you decide to stop. Here are a few examples of these plots on 10,000 data points of a Gaussian distribution, an exponential distribution, and a uniform distribution. You can see a clearer view of the distribution using the enhanced box plot. The uniform distribution can also help explain what these boxes represent. You can see the median plotted at 0.5. The first set of boxes go from 0.25 to 0.75. The next box looks to start at about 0.125, and each box should be about half of the size of the previous box. The authors came up with 4 potential ways to stop making boxes. Number 1, you can decide you'll keep making boxes until there are only 5 to 8 points outside of the boxes. 2, you can decide to use a fixed proportion of data points outside of the boxes. 3, you can make boxes until your data is not good enough to make a trustworthy prediction of the box based on confidence intervals around that location. And the 4th way is similar, again based on trustworthiness, but using a different approach to define that term. Now let's take a look at how these enhanced box plots look in Python. First, let's import NumPy, Seaborn, and Matplotlib. What we're going to do is take data points first from a normal distribution. Let's just start with 10 data points for now. And we're going to make 2 plots side by side, a box plot on the left and an enhanced box plot on the right. They both look pretty similar. In this case, the enhanced box plot built into Seaborn thinks that we don't need additional boxes to represent the 8ths, 16ths, and more. But if we increase the number of data points, we can see that the number of boxes on the enhanced box plot increases. We can choose when Seaborn will stop making additional boxes using this k-depth parameter. So for example, we can set it to trustworthy, and we can see something pretty similar in the previous case. It's hard to tell a real difference between these different stopping points. But you can try out several different kinds and see which one you think looks the best for your data. I think the enhanced box plot really stands out and looks a lot better than the normal box plot when we're looking at different distributions, such as the exponential distribution. Here we can see a much clearer view of what the distribution looks like using the enhanced box plot, and we don't have all of these points that are labeled as potential outliers like on the box plot. Another interesting distribution to look at is the standard t distribution. And here again you can see that our enhanced box plot provides a lot more information and it is a lot cleaner to look at compared to the normal box plot. I hope you all enjoyed this video. Thanks for watching.